For more than 40 years, the Pacific Ocean along the coast of Panama followed a reliable natural rhythm. Every year, usually between December and April, the sea would breathe. This breathing was not air, but cold, nutrient-rich water rising from deep below the surface. Scientists call this process upwelling. It happens when strong seasonal winds push warm surface water away, allowing colder water from below to rise up. This cold water brings nutrients that feed tiny plants called phytoplankton, which then support fish, coral reefs, and the people who depend on the sea for food and income. In early 2025, something shocking happened. For the first time since scientists began measuring this region with modern instruments, the seasonal upwelling in the Gulf of Panama almost completely failed. The sea did not breathe as it normally does. Satellites looking down from space and fishermen working on the water both noticed something was very wrong. The ocean surface stayed unusually warm, the water did not mix, and marine life began to disappear. This event surprised scientists because the Gulf of Panama is one of the most dependable upwelling systems in the tropics. Unlike temperate regions such as California or Peru, tropical oceans are usually warmer and more stable. When upwelling occurs in the tropics, it is especially important because it cools the water, feeds marine life, and protects coral reefs from extreme heat. Losing this process, even for one season, is a serious warning sign. During a normal year, strong winds blow from the north across Central America. These winds form what scientists call the Panama wind jet. When this jet is active, it pushes the surface water of the ocean away from the coast. As that warm surface water moves aside, colder water from deeper layers rises to replace it. This deep water is full of nutrients that have settled over time. When the nutrients reach the surface, they feed phytoplankton. Phytoplankton are microscopic plants that float in the ocean and use sunlight to grow, just like plants on land. They are the foundation of the entire marine food chain. Small fish eat phytoplankton, larger fish eat small fish, and so on. Without phytoplankton, the whole system weakens. Satellites can detect phytoplankton by measuring chlorophyll, the green pigment plants use for photosynthesis. In a healthy upwelling season, satellite maps of the Gulf of Panama glow red and green, showing high chlorophyll levels. These colors mean the ocean is full of life. The cold water that rises during upwelling also cools the sea surface temperature. In strong years, temperatures can drop to around 19 degrees Celsius. This cooling is extremely important for coral reefs, which are very sensitive to heat. Cooler water helps prevent coral bleaching, a process where corals expel the algae they need to survive. In 2025, this entire system broke down. Satellite images showed something scientists had never seen before in this region: extremely low chlorophyll levels during the peak upwelling season. Instead of glowing with life, the ocean surface looked empty and depleted. When scientists went into the field and measured the water directly, they found that the ocean layers were strongly stratified. This means the warm surface water stayed on top and the colder deep water stayed below, with very little mixing between them. The normal vertical movement of water simply did not happen. Cooling also arrived late. Instead of beginning in late January and lasting about 2 months, the cooling in 2025 came weeks late, lasted only briefly, and never reached the usual low temperatures. The water stayed closer to 23 degrees Celsius, which may not sound very hot to humans, but is stressful for marine life adapted to cooler seasonal conditions. A major scientific paper describing this event was published in Proceedings of the National Academy of Sciences, one of the world's most respected scientific journals. The researchers concluded that this was the first time the Gulf of Panama's upwelling had failed in the modern scientific record. The most important discovery was that the failure was not caused by a lack of cold water deep in the ocean. That cold water was still there, waiting below the surface. The real problem was in the atmosphere above the sea. In 2025, the Panama wind jet formed much less often than usual. When the winds did blow, they were about as strong as in previous years, but they did not last long enough or occur frequently enough to push the surface water away. Calm periods between wind events were longer, allowing the warm surface water to remain in place. This meant the ocean never reached the threshold needed to trigger strong upwelling. Scientists describe this as a system crossing a critical tipping point. Once that point is crossed, the entire process can collapse very quickly. Biologist Aaron O'Day from the Smithsonian Tropical Research Institute summed it up with a powerful phrase. He said that the tropical Panamanian Sea has lost its vital breath. This description captures how essential, Upwelling is to the life of the ocean. Another researcher, Ralph Schiebel from the Max Planck Institute for Chemistry, explained that this was the first time scientists had directly observed how changes in wind and ocean circulation could cross a threshold and cause a sudden drop in biological productivity. Scientists are cautious but concerned. Climate geochemist Gerald Hogg emphasized that it is still too early to say whether global warming alone will permanently weaken this upwelling system. 1 year does not make a long-term trend. However, the event fits broader worries about climate change. As the planet warms, wind patterns are changing. Trade winds in some regions are becoming weaker or more irregular. Warmer surface waters also increase stratification, making it harder for deep water to rise. In other words, climate change may not have directly turned off the upwelling in 2025, but it may have made the system more fragile and easier to disrupt. What once was a stable, reliable process may now be vulnerable to small changes in wind and temperature. The effects of the failed upwelling were felt very quickly. With few nutrients reaching the surface, phytoplankton populations collapsed. This weakened the base of the marine food web. Fishermen reported sharp declines in small pelagic fish such as sardines and mackerel. Squid and other cephalopods also became scarce. These species depend on productive waters rich in plankton, and when that productivity disappeared, so did the fish. Coral reefs suffered as well. Normally, the cool upwelled water helps protect corals from heat stress during the dry season. In 2025, without that cooling, corals were exposed to higher temperatures for longer periods. This increased the risk of coral bleaching and long-term damage to reef ecosystems. The scientists warned that if upwelling failures happen repeatedly, fisheries productivity could decline permanently. Coral reefs, already stressed by warming oceans and pollution, could face even greater threats. For coastal villages and small-scale fishers around the Gulf of Panama, this was not just a scientific curiosity. Many families depend directly on seasonal fishing for food and income. The upwelling has supported human societies along this coast for centuries. When fish disappear, livelihoods are threatened. Food becomes more expensive, incomes drop, and communities become more vulnerable. A single failed season can already cause hardship. Repeated failures could lead to long-term economic and social instability. This event highlights how closely human well-being is tied to natural ocean processes. When the sea's rhythm changes, people feel the consequences almost immediately. One of the most troubling aspects of this event is how easily it could have gone unnoticed. Major upwelling systems in temperate regions, such as those off California or Peru, are closely monitored with dense networks of instruments. In contrast, many tropical upwelling systems are poorly observed. In Panama, scientists relied mainly on a 40-year satellite record and a few coastal stations. Detailed observations were available only because a research yacht, the S.Y. Eugene Siebold, had begun systematic surveys just 2 years earlier. Researcher Hanno Slagter pointed out that without this mission, no one might have known the upwelling had stopped. This raises serious concerns. Similar breakdowns could be happening in other tropical regions without being detected. The authors of the study argued that the 2025 Panama event should be seen as a test of resilience for tropical oceans. It shows how quickly a critical system can fail when pushed beyond its limits. Whether this was a rare anomaly or the beginning of a new pattern depends on future changes in wind, climate systems, and greenhouse gas emissions. If global warming continues unchecked, the risk of more frequent and severe disruptions will increase. Strengthening ocean monitoring networks is essential. Better data would allow scientists and policymakers to detect problems early and respond more effectively. Fisheries management also needs to adapt, taking into account the possibility that long-standing seasonal patterns may no longer be reliable. Above all, this event reinforces the urgency of reducing global greenhouse gas emissions. The stability of ocean systems that support life, livelihoods, and food security depends on it. For decades, the people and ecosystems of the Gulf of Panama have lived in harmony with a seasonal rhythm in the sea. That rhythm once seemed guaranteed. The events of 2025 show that it is not. The ocean's breath can falter. When it does, the effects ripple outward from microscopic plankton to coral reefs to fishing communities. The lesson is clear. Even systems that appear stable for generations can change suddenly in a warming world. Protecting that rhythm will require better science, wiser management, and collective action to address climate change. The future of tropical seas and the people who depend on them may depend on how seriously we take this warning.